Hi, hello everyone. Welcome to the Software Services channel. Hope you are all doing good. So let us discuss something useful today. So, we are in the basics of cloud computing concepts series, friends. So, in the last classes, we started discussing the agenda of this cloud computing, course. Now, in today's session, we'll discuss the first concept of the course, that means traditional computing. So, what is traditional computing? Let us discuss. Okay, right now. So, the traditional computing, in the sense, friends, it's very simple. So, last 10 years, back, we are all doing these things only. In which, if an organization is running some web applications or some software. So the organizations need their own servers, their own uh, power supplies, their own storage systems. Everything organization needs to purchase somewhere, and then they need to fix all those purchased big servers, routers, cables, power supply, generators, everything, hardware, software, all the things into one big hall, which uh, they'll call it as on premises, or it is another with a famous word called data center. Okay, so the organization owns all those hardware resources and the software uh, you know, licenses, or everything from A to Z. For what? To run their uh, IT applications. IT application, in the sense, it may be a web application, it may be a desktop applications, or any kind of computer applications. It may be, the organizations needs to have the backed by the hardware and the software, so which they have to procure, and they are maintained in their own data centers. And that is the key takeaway, friends. Okay, so this is also called on premises computing. Okay, so another word is they are having their own data set. Right, moving to the next. So let us see how it looks like. So data center, in the sense, so it is equipped in a big hall with all these racks. So in these racks, they are having routers, big servers, and storage systems, routers, switches, everything will be there. So that is maintained by their own staff. Okay. So data center, in the sense, in these building, they are having compute in the sense, servers and storage and all the interconnecting wires, networking. All these are get together, known as, called as data center. So who owns this data center? The organization which needs to run their web application owns this data center to run their applications. That is all about the on-prem data centers, which is a part of traditional computing. Okay, so let us move. Uh, so let us spend some time discussing some characteristics of traditional computing, or maintaining a own data center. So that means traditional computing. So broadly, one, two, three, four, five, six, seven, 8 points. So I will quickly touch upon these uh, points, friends. Okay. So when it comes to traditional computing, who is the owner of all the infrastructure? Infrastructure in the sense anything it may be, servers, switches, routers, the storage, hard disks, all those infrastructure. Who owns in the sense the organization or the company owns. Some ABC company is there. ABC company is running some software or some of web application. So that ABC company owns this infrastructure, right? And the capital expenditure and operational expenditure. So capital expenditure and operational expenditure means, the ABC company needs to purchase the servers, big servers, right? In order to host their web applications from the market. So they needs to purchase, that is a capital expenditure, and to run that servers, storage systems, networking devices, power supplies, generators, backup battery, and UPS, everything. For that also, some expenditure will be invested, right? So happen. So that is called an operation expenditure. So it's an the company, the ABC company will have to purchase the required IT resources, and to run that IT resources also they need to spend a lot of money. So this is what we are have been doing from last before 10 years back. So, and resource scaling. So resource scaling in the sense, so if that ABC company, if a company buys some, say, suppose say, uh, 50 GB of RAM, okay, for its workload. So then what to talk of if the need is going up in the sense it is not enough for running their application. So on this day 50 GB is there, may probably in coming months the same IT workload, because of the traffic it goes to uh, 70 GB, 100 GB of RAM is needed. So then the ABC, that company, needs to upgrade that RAM. Okay, resource scaling is very tough. Okay, and also after purchasing 100 GB of RAM, so if again the traffic comes down, then the 100 GB RAM is goes waste. What I mean is, so the company had procured more than needed. So that resource scaling is very tough thing, tough to estimate. Okay, so even though organization doesn't company doesn't need that much of infra, once it buys, they have to keep it with them. Okay, so lot of money will be wasted here. And the maintenance and management, all the hardware and software infrastructures need to be maintained by the company itself. That means they have to hire engineers who will maintain those data centers. So who will take care of the servers, storage systems, networking, routers, switches, all the engineers. They need to hire, and they need to pay the salaries and everything. Okay, and limited flexibility in the sense, for example, say we are having on a web application that we deployed in the on-grid. Okay, So now my business is expanding, and it is expanded from India to the USA and the Europe also. Then what I need to do? So Europe customers and US customers necessarily uh, come to India based data center servers. Okay, comes to in the sense they needs to connect to the India uh, data center, right? Because in US and Europe, I don't have any data centers uh, of my own. Okay, then what will happen? The US customers and the Europe customers may uh, feel slowness when browsing the websites. Okay, so the flexibility in the sense we cannot expand our data center or IT resources, and the location dependency is also the same as which I spoke in this point. Both are interdependent. So location dependency in the sense, so we are from India based only, but we cannot expand. So that much of location flexibility, and also the resource scaling up and scaling down in the sense, so whatever I need, so I can increase and automatically I can decrease the RAM capacity or the CPU capacity or the storage capacity. So once we brought it, that's it. So it will be useless when the traffic will come down. Okay, and then the security and compliance. So security and compliance in the sense, so the company who is maintaining the data center is having a whole and soul uh, high-handed control on their own data center. So nobody can enter into that. Nobody can, it is an isolated, fully protected, and they will implement their own security policies and compliance uh, methodologies. Okay, so that's one, and the upgrade cycles. Upgrade cycles in the sense, for example, so now that the company which is running their web applications on top of the servers, that servers needs to be upgraded, right? So if I uh, deployed the website today, maybe after 2 months, the security patches will be upgraded. I mean, the OS level, operating system level, right? And also the hardware level. All these upgrades should be uh, taken care by the company itself uh, with their own engineers. Okay, so all these things are the characteristics of traditional computing, friends. Okay, so I hope you understood the concept behind uh, the computing. That means traditional computing. So 1, 2, 3, 4, 5, 6, 7, 8 points we discussed. In the next slide, in the next class, in the next session, we will discuss the uh, cloud computing. Okay. Till then, bye bye. Yours Veera signing off. Thank you, friends.